So building on the previous video, here you can see we've got the setup hardware for the LED exercise. What I'm first of all going to do is just save this. You can see I've got it here saved in a folder on my desktop. I'm just going to save it at the top of that, so LED. For quickness, what I'm going to do is I'm going to get the blocks by just simply double clicking on my left button and just you can see I can double click on here and get the blocks that I need for this particular exercise. I'm not getting them in any particular order. You can see here I can just literally just move them close and then they automatically connect together. On the PWM, so you can see this. So once you get familiar with this a little bit more, you'll get used to how quick it's doing. So I'm literally just left clicking double, typing in, and I don't need to type in the full, and then just clicking on what I want, and then it's providing me with the block that I'm after. So you can see here what I'm doing is just connecting them up now. So I'm just clicking on these, left clicking on here. Now I'm going to set up the block. So I'm going to go into the sine wave, I'm going to double click on that. I'm going to change this to sample based. I'm going to change this to samples per period, 300, and then I'm going to do the sample time of 0.01. Absolutely don't need to do anything with that. And then the slide again, I'm going to change the upper limit on this, the high, to 255, because for this particular Arduino Uno it's 8-bit, so it means we've got 256 levels, so from 0 to 255. Finally, if you remember when we were setting this up, we used pin 9 for the pulse width modulation. So if you go back and look over here, you can see pin 9, although it's not the easiest, but I do promise you pin 9 there has in fact been used, although it does kind of look like it's pin 10. Right, so that's pretty much set up. What I'm going to do is just move this slide. So this enables me just to move from 0 to 255 in terms of all those different levels. Obviously it'll take it in terms of intervals. So what I'm going to do is just put that at 255 to begin with. Usual setup, so I'm going to change that to INF, so infinity. I'm then going to go into modeling, go to model settings. I'm then going to go to hardware implementation, just select the board, so Arduino Uno. And then in terms of what I'm going to do, I'm going to select what port I'm using. In this case, I'm going to go manually select or manually specify. I know because I went to device manager. I looked up in here and I was using COM4, so I'm just going to put 4 in there. Okay. Then finally, monitor and tune. I'm going to zoom on that so you can see that a little bit bigger. Monitor and tune, that'll take a few seconds now to run. So what we'll do once this is running, you should see the LED increasing and decreasing in brightness. It should be doing it kind of in, I guess, phase with the sine wave. You'll notice that actually it's not a sine wave because I'm going to go through each one of these scopes and show you effectively exactly what's happening. So if I go to this first one here, so this is why Simulink comes in, it's so good, it's so quick to be able to view signals. So you can see a typical sine wave in this case, although we didn't change any of the properties of this, but the amplitude, we didn't change the amplitude here is just 1, and hence you can see the amplitude here is 1, between -1 and 1. Using the absolute block, which is what that is going to do effectively, is just convert all the positive signals, the negative signals to positive. So you can see there now, rather than having the sine part as the negative part, it's like a bouncing rabbit. I always kind of look at it when I think this, it's like bouncing up and down. There's no negative values. And then finally, because we're multiplying it by this slide again, what you'll now see is values between 0 and 255. That's convenient because the PWM is running, which requires values between 0 and 255 for all the different levels, the 256 different levels. Right, so what we can do is, just as a quick one here, I'll click on the slide again. I'm going to just lower that to, 130. And what you'll now notice is we can actually look at the signal in real time, and you'll notice now that signal now is, the amplitude of that is 130. What you'll also notice is the brightness of that obviously is decreased because now it's running at much lower power setting, and we can take it all the way to 0, turn it on and turn it all the way up. Okay, so you can see all the signals in real time, so it's very, very kind of intuitive in that manner. So I hope you found this video interesting. Thank you for listening.